I welcome Abhishek. So, in today's mock interview round, we are taking multi-agent systems interview questions for forward deployed engineer generative AI, and we'll be discussing. You have to explain us how will you design, troubleshoot, and defend production grade multi-agent systems for enterprise customers on, let's say, Google Cloud, including architecture, orchestration, reliability, observability, security, and customer-facing delivery trade-offs. So we're going to get started with the first question. And the first question is, how would you decide whether a customer problem should use a multi-agent system instead of a single agent workflow?
Okay, so for this particular situation, I would start with the task decomposition, not from a multi-agent perspective. So I would look at a few things like the role separability. So can the work be, splitted into some distinct sub-responsibility with, different tool data access or a reasoning style? uh, for example, there is a retrieval agent versus some compliance checking agent or some report writing agent. So if one well prompted agent, with the right, if one well prompted agent with the right tool can already do it end to end, so I would keep it single agent, because every extra agent would add some coordinated cost. Then there has to be some decision boundaries and also some parallelism. So suppose if subtasks can run concurrently and need independent context window, to avoid prompt bloat or some context poisoning, or require different guardrail per domain, depending upon the business requirement. Let's say if it's a BFSI use case, so here risk scoring agent would need some audit, then some document summarization agent. So that would be, real signal for to go for a multi-agent. And the cost of failure and the observation need would be there. So in an regulated or let's say enterprise setting, uh, there has to be some coordination overhead, or uh, some latency against the I would say the modularity gain. So a simple agent is easier to trace and is cheaper to run. A multi-agent buy you a separation of concern, obviously, and some fault isolation, but no at the cost of orchestration complexity. So inter-agent latency and harder root cause analysis when something goes wrong. So this situation might occur. So like the multi-agent is a cost I pay for modularity and parallelism. So I only pay it when the business decomposition demands it, not by default. Yep.
Okay, great. Let's get to the next one. Okay, so the next question is, design a production grade multi-agent architecture for an enterprise knowledge assistant on Google Cloud.
Okay, so I will answer this question based on the recent project which I shipped. So it was a BFSI compliance risk system, and it was multi-agent.
Okay,
So
and if
uh, you
you
know
want, you can share your screen and you can design that system also. This is a system design question, so you can do that as well in case if you're comfortable. Just
uh,
let me know.
designing part. Yeah,
Otherwise,
like
you can continue
notepad.
speaking.
Yeah, I will look for it. Actually, there are draw.io. These things are there.
Okay. So you can share
But
your screen. I can stop my screen for a moment.
okay. Let's say okay. Let's say we have uh, intent initially. What need to be done. A second text into. So let's say we have some intent.
You
Okay.
have Increase the size so
Now,
that it is visible.
this intent would be okay once again.
Increase the size of the screen. You can use Control plus plus to increase the size of the screen. A little more.
Now,
Now this is fine.
okay. So let's say we initially have an intent is it could be some kind of prompt. So before we initiate the workflow, there has to be some coordination layer, a planner agent which classify the intent, whether it is a factual lookup or multi-step reasoning, or it is an action, and route it accordingly. So here's some Landgraph state. This can be a some Landgraph state machine rather than free from agent loop. So there has to be deterministic routing. It would make it easier, and the auditing would be easier. So let's say if I make an arrow to this, and let's say it is a classifier agent. No, one second. Root word text. Not getting. Okay, one second. Let's say it is a planner agent, and it would it would have two things. So whether it is a factual reasoning, uh, this line, okay, or it is some kind of multi-step reasoning, or or is it some kind of some kind of action. So Devanshu, actually I need to practice this draw.io a little bit.
No problem. You
So
can resume the answer. You can stop the share and resume answering the question.
I'll practice it some, and then you know.
Yeah.
So yeah, I was at the coordination layer. So obviously there has to be coordination once the intent is fed to the system to determine the routing, and also to uh, audit. mm, It would make the auditing easy. So then there would be, second layer, it would go to a retriever agent, It would query a hybrid RAG pipeline, vector store. It could be, a Vortex AI vector search or some managed store like Pinecone, plus obviously some metadata filter for access control. So retrieval respects the document level permission and not just the semantic similarity. So this matters a lot for enterprise knowledge assistant where not every user should see every document. Second would the post this would be a synthesis layer or a synthesis agent. So it would draft the answer strictly from the retrieved evidence with citation back to the source chunk from where the data has been taken. And this is where we do the ground we enforce the groundedness to our answer. And at last we can add one verifier agent or verification layer. It would check few things before anything is actually shipped. So first is the factual groundedness. Does whatever the claim is, does it retrieve to some relevant evidence or not? Then there has to be some policy compliance, or to check where there are any PII leakage or anything like that. And also one confidence threshold. So below threshold, it would fall back to human in loop rather than hallucinate the answer, because there could be situation where we don't have the answer in our context, or we don't have the relevant evidence to answer the query. And we can add one action agent, so it would be an optional path. So it would only invoke for task completion request, and it would calls the some enterprise API with least privileged credential. Mm, so, yeah. Orchestration, we can add the orchestration or asynchronous handoff between agent. uh, for persistence, we can add durable state in any of the database.
Mhm.
Yep.
Okay, let's get to the next. Okay, so the next question is, how would you manage shared state and memory across agents in a multi-agent workflow?
So for managing memory, it mu- you know it has to be, I would say, separated into various layers of state model. So there has to be one workflow state. So obviously it has to be structured and it has to be durable. So it would store the current task, the intermediate output, the tool calls, routing decision. So, and it has to be, when I say it has to be durable, it must be, it must survive the crash. So it should go to some persistent database, and it must must be checkpointed with the session ID. Mm. So if suppose the process die mid-run, so I could resume from the last checkpoint instead of restarting the whole workflow. Then there has to be conversational memory, which we have in any of this AI chatbot, or session memory. So it just need to have enough context to keep the interaction coherent, not a dump of every prior turn. So it would keep it lightweight. So
Okay.
and yeah, there has to be long-term, uh, some long-term knowledge, like external thing, not in an agent, so which lives in enterprise system for record, like retrieval indexes or database, never as free from agent memory. So this would keep the source of truth somewhere.
Okay.
And we must add the coordination rule, like kind of explicit ownership. Each agent can only write specific fields in the shared memory, not arbitrary read or write access for everyone.
Mhm.
So it would prevent our conflicting updates.
Mhm. Okay.
Yep.
Okay. So let's get to the next question. The next question is, what failure modes have you seen or would you expect in multi-agent systems, and how would you debug them in production?
Okay. Failure modes. So there could be, in a multi-agent system, there could be failures at various level. So, so I mean, whatever, like the last project which I worked upon, depending upon that, uh, I could pinpoint few places where it generally happen. So first one, at the routing loop, the the planner keeps bouncing a task back and forth between two agents because neither output satisfy the other expected schema. So there is some mismatch in the schema layer. Then there is situation where there is a hallucinated handoff. There is some kind of hallucination. An agent claim it called a tool or retrieved some evidence, but it didn't actually. And the downstream agent trusts that claim and build on nothing. So it's a completely garbage. And then there are race conditions. I mean, race conditions are anyway in the situation happen. So the two agent, read the shared state at, let's say, a slightly different time, maybe one after the other or almost exactly at the same time. And one writer's tail override that that kind of mix up with the newer update. So, yeah, and there could be tool misuse also, like authentication token expires mid-run, or there is some schema mismatch between what tool expect and what agent send, or an agent is calling a tool with some hallucinated parameter. And obviously, if one agent is slow, then it would create a timeout cascade because it would time out everything, the backend also. If one timeout, then downstream also it will hang, or it will fail ungracefully. So for every run, gets some, we need to get some correlation ID that ties together the log and traces and state snapshot across all agent. Suppose when something breaks, so I don't start reading logs from top to bottom. I would I defer the the state object at each checkpoint to find exactly where it diverged from the expected shape, and then we can zoom into the agent prompt and tool input IO at that step. So, and yeah, we can also add a mitigation to it, like maximum. We can set maximum hard limit to kill the infinite loop, or schema validation on every agent handoff. There has to be schema validation, and so, and also retries should be for transient error. If there is a logic error, so anyway it will fail if there is a logic error. And deterministic fallback must be there, like human escalation where the confidence drop below certain value.
Okay. Okay. Let's get to the next one. So the next one is, how would you evaluate a multi-agent system beyond standard LLM response quality metrics?
Okay, so it, so the standard LM metrics could be, the fluency or the coherence. Tell you almost, it would tell almost nothing about where, whether a multi-agent system is production ready or not. So, uh, so definitely it need to be split into, end to end per agent wise, the whole workflow. So end to end mean, does the system deliver the business value or not, like task completion rate, answer correctedness against the ground truth, groundedness, does every claim trace to a retrieve evidence or not. And this is even used in ragas for ragas kind of check in production. Then latency, eh, we can go for P50 feed, P95, all these. We can add these things. We can add a cost metrics also, and the escalation rate, like how often it reaches to the human. If too high mean the system isn't pulling weight. Too low mean the verifier isn't catching enough. So there has to be some balance. Then when we come to the per agent, where does it actually break? Then like first we need to check the accuracy of the routing agent, the router, where it is sending. Did it send the task to the right specialist or not? Then the if it is sent to the right agent, then what is the retrieval relevance? So what is the precision or what is the recall on the retrieved chunk against the label set? And the if that too, if that too is okay, then what is the the verifier agent success rate or verifier agent catch rate? So what fraction of bad answer actually got before delivery? So this metrics would mean a lot. uh, and also there has to be a tool execution success rate, whether it executed or not, and the loop rate, how often run needed, then for every specific routing problem.
Okay. Let's move on to the next one. So the next one is, suppose a customer wants a multi-agent workflow using LangGraph, QAI, or ADK. How would you choose and justify the framework?
Okay. Mhm. So it's multi-agent workflow. Okay. Let's compare framework. Actually, this one can we do tomorrow because I have worked on LangGraph, but ADK, all these comparison need to be answered here.
Certainly, we
Uh,
can take it tomorrow. No problem. Let's get to the next one. How would you secure a multi-agent system that can access enterprise APIs and internal data?
okay. So there has to be, I would treat every agent and every tool as its own, security boundary. No shared credential. So there has to be, identity and access management, least privilege per agent. So each agent gets a scope service identity, not a shared API. A retriever agent's credential can read from the vector index and permitted document store, nothing more than that. Let's say an action agent that files the ticket gets separated scope credential limited to, ticketing the API with no access to, let's say, its financial system. Or one agent, if suppose one agent's credential is compromised, the blast radius would be bounded to that agent. Not it won't go, anywhere else. Then data access level, we can have classification aware retrieval. So suppose retrieval enforce a document level permission and metadata filter before anything reaches to the model. This has to be done, because the LLM should never even see the content the requesting user is intent authorized for. So this is a retrieval time control. So that that we can add. So we can add some metadata prompt like not to show restricted docs. So and we can add some policy gate and human approval at certain stage if the business requirement allow. And like we can audit the we can audit the logging, full trail start to end, every run log, who requested what, which agent acted, or what data was accessed, what tools were called, and what actions were taken.
Okay.
So in a nutshell, it has to be a RBAC scoped per agent role.
Okay. Okay. Great. Let's get to the next one. The next question is, describe how you would integrate a multi-agent system with existing enterprise infrastructure during a forward deployed engagement.
Okay, the first, I would try to understand the existing infra, before taking any action. So let's say, the forward deployment succeed or fail on the discovery, not on the model quality. So before, writing any piece of code, I would try to map few things, like, how the systems or how the APIs are placed, or from where the data is sourced, where it live, what are the already API accessible versus what is locked in some legacy interface, and if that need to be accessed, so how we can resolve it at infra level. Then obviously there has to be some permission IAM control, identity and permission control, that need to be understood, like how does the customer IAM work, and can I be able to get a scope service account per agent, and critically, does the document level access mm, control already exist upstream, or do I need to build it? Then there has to be a data quality check, and the SLA agreements which have been made with the client, and approval workflow, where does the human fit within the workflow, or we need to place the human after every intent or after few intent classification or routing, and and like for integration, I would try to build a adapter layer between the multi-agent system and each enterprise system. It could be legacy system or whatever it is, rather than hard coding some customer specific logic into the agent themselves. So the agent would talk to some stable internal interface, and the adapter would just absorb whatever is messy to the legacy API. And yeah, so
Okay.
yep, so this is how I would approach.
Okay. Sure. Let's get to the next one. So the next one is a multi-agent RAG workflow is returning inconsistent answers to the same question across runs. How would you diagnose and reduce that inconsistency?
Okay, so this is a situation where uh, where we I won't guess the cause, and I would try to isolate which layer is introducing this cause, this variance, by comparing the full trace of mm, of the repeated run. So it could be at any of the layer. The first could be the retrieval variance at the retrieval layer itself. If the same query return different chunk across different run, and then I would check the chunking boundary. Is chunk split differently if the source docs are re-indexed, or the metadata filter behavior or the ranking algo style, and obviously the index freshness. If suppose this retrieval layer, we don't find anything, then we can go for the routing at the routing layer if there is some variance at the routing. So if the planner classify the same intent differently across run or not. So this would usually mean, right, the classification threshold is too close to the distant boundary, or or the planner prompt itself has enough ambiguity that that borderline intent get randomly bucketed, and obviously the end output is not acceptable. uh, then yeah, we can look at the state or the context difference. If there is a prior session state or conversation history between the run, that is causing the same question to get different context injected, and if we have some cache clearing after each run or not. Yeah.
let's take one more question. So this question is, tell me about a time you had to simplify an AI architecture or push back on a more complex agentic design.
Okay. So I will take the example of my previous project, AIG, where I work in the BFSI vertical. So, on the AIG BFSI engagement, we were building a production agentic system, and the initial design proposal called for a multi-agent setup. So, the separate specialized agent for classification or retrieval or validation, the response generation, each with its own, LLM call in the chain. So my task or my job was to, get this to production with strict latency and, cost constraint. So this was a regulated environment where every additional model call would add both latency and audit. And the business had a hard SLA target to, to complete or to deliver. So I benchmarked the proposed multi-agent chain against against a linear alternative, considering all constraint of the environment, which a non-technical leadership won't understand. A single well-structured orchestrated workflow that would, combine the classification retrieval in one pass with validation as, separate deterministic rule based on check rather than another LM call. So I ran both version against, our evaluation set, and the measured the latency or cost per request and accuracy side by side. So the data showed the linear design met the same accuracy bar while cutting the latency significantly,
Okay.
and reducing per request cost. So the extra agent hop in the original design were adding, overhead without adding a measurable accuracy gain. So they were adding complexity because it felt more, more through, but not because, the eval showed it helpful. It was just a preconceived notion from the leadership to go for, the multi-agent is better than a single agent. So I brought this to, to the team, like, this is what my findings are, or this is what my analysis are. And we tested the trade-off data, and then here, we went to ship the linear version to hit the SLA, because at the end target was to meet the SLA with the client. We can improvise on top of whatever we ship at the required time. So yeah, that's how, I dealt with, and uh, we shipped the streamlined architecture, and we hit a significant latency reduction. Obviously, it was not up to the mark of the client. We had to improve on that, but it was significant, and obviously, it was significant cost reduction because we had a this thing, single agent versus multi-agent cost trade-off.
Okay.
Yep.
Okay, great.